My name is Mike Altman, and I'm the Director of Sales in the Custom Solutions Group of Goodman Networks. The Custom Solution Group has been designing and deploying gas systems for 14 years, and many of which of these systems have been installed on college, university, and campuses. We presently have a large project underway at Duke University and completed other projects ranging from community colleges to Division II schools, clear on up to larger facilities like Duke University. And before starting in my formal presentation of the 10 keys, I thought I'd just touch on what makes college installations so unique and why the preparation and addressing the key elements we're going to talk about today are critical for a DAS installation. So of all the types of projects we do, campuses pose the most unique and challenging environments for a DAS installation. Depending on the size of your facilities and size of the campus, there's a variety of buildings and environments, each having their own very unique DAS and RF infrastructure requirements. That can include simply a hospital, should you have one on campus, of course, stadium, auditoriums, you've got offices, dorms, public facilities, a wide range of buildings that all have different needs, different groups of people with varying goals and objectives. At the same time, these buildings are spread out over large acreages with different terrains, oftentimes large trees or obstacles, and it makes for a very interesting and challenging installation, particularly from the design perspective. And within that large area, we have a very mobile and fluctuating user base. If you have a popular auditorium or a sports venue, users will flow in and out of your campus, but you'll find perhaps on a weekend a tremendous amount of visitors to a particular event, and that's going to impact as well how the system's designed and what you need to put on your campus. And in addition, and I think as most of you know, the utilization of smartphones has put a heavy demand on data usage, and that's going to increase very significantly. I'll touch on that in a moment. But as data usage increases and the different types of venues evolve on campus and the user evolve on campus, then you're going to see quite a burden on the systems. And as mentioned, again, there's a very diverse user base. So you've got students, administrators, professors, researchers. You've got first response radio, campus police, a wide range of users, all who have a different need and requirement as it relates to the DAS deployment. Touching on the data usage and the demand on data, I saw an interesting slide the other day. College students have an average of 6.9 gadgets per student. Seemed like a huge number. 70% of them own a smartphone, 35% own a tablet, 85% own a laptop. I was recently at an exposition, and the hot thing there was wearable devices. Those require signal. You're seeing all sorts of new applications and devices that are driving the new device explosion, of course, a demand for systems. All of this means and adds up to really to address kind of the key top 10, what I feel is the top 10 things we need to address for a DAS installation, and let's move on to that now. So this is kind of like a David Letterman's top 10 list to some degree, and I'm going to start right at the top here. And the number one thing that needs to happen, we feel, is a solid wireless needs assessment. And that really starts with basically, who needs coverage. I touched on the diversity of the user groups there, but an assessment needs to reach out to facility managers, different departments. I mentioned police and fire radio, determine what their current coverage situation is like, how it's being used, where is coverage needed. And the coverage need situation can be based on the survey that you send out and be it more an anecdotal description. Okay, I'm having problems with coverage in the basement or certain areas, but it can also be more of a sophisticated benchmarking design review type proposal that's prepared by an RF technician, and they can walk the facilities with the various equipment and mapping software that will really give you a true picture of where there's coverage needed, what the extent of the shortcoming is on the campus. At the same time, while they're doing the coverage needed piece of this, you need to also evaluate what's existing, what systems may be on the campus now, and how can they blend with any new systems you're proposing. It's very frequent in a campus environment that a campus may not have the budget to do a total DAS deployment. So in the meantime, different departments are putting in their own disparate systems, and you may find that as you do the coverage analysis, some buildings will have a repeater-based system, perhaps a DFEMTO or small cell system in place. And that coverage assessment is an important part of determining what's existing and what can be used and where the overlap may occur. The other piece of this that's important, and it kind of goes to the ROI of these systems, is really why is it important to the people who are going to be using the DAS to drive applications on your campus. And it can start with just simply, I need to complete a call. I'm a facilities manager. I'm down in a dingy basement working on the heating and HVAC, and I need to complete a voice call. For a student or someone at, say, a hospital, it could very much be a data throughput issue. They need to get through and be able to complete communications involving data applications, and whether that be a specific application involving moving data, or that be video streaming or taking pictures. It can be any number of things related to data throughput. At the same time, you need to talk to your first response people, your campus police and security, and understand what the system means to them. How is their systems working now? And how can you integrate the DAS system into first response radio? This is frequently overlooked, but it's critical because you have an opportunity when you install a DAS system to piggyback public safety support onto that system, and at the same time meet some ordinance requirements that may require you in the near future to validate that the systems are going to be working and will support police and fire radio first responders. And finally, we need to do an assessment of what technologies need to be supported. And those technologies could be include, for example, not just voice, but Wi-Fi related applications and technologies. Again, the new DAS systems have the ability to do some piggybacking of Wi-Fi systems, and you need, in your assessment, it's a great time to understand what's happening with regard to Wi-Fi and the unlicensed frequencies. I touched on public safety, vital to understand what's going on in the public safety arena. And of course, simply just straight voice technologies. LTE is on its way in many communities. But again, in your assessment, understand what technologies you need to support today and even downstream in future years as you get ready to make a quite large investment into DAS deployment. The second piece of this is it's critical that you engage the wireless carrier very early on in the process. And the wireless carriers have made a huge investment in wireless frequencies. You need to treat it almost as a resource that they own. So they're going to need to approve any systems that are retransmitting their frequencies. And right off the bat, let them know what your plans are. There's no exception to that policy. The carriers own airwaves, and at the same time, each of the carriers, the major carriers, have teams in place to help their customers improve wireless coverage on their campus. And those teams can help with the assessment process, the evaluation of what's needed. They also have access to potential funds that may help offset some of the costs of the systems. At the same time, because the carriers are deploying so many in-building systems, they can make suggestions as to who to go to with regard to an integrator or a particular OEM. They're going to be looking at the design very closely, and they'll approve that and make suggestions with regard to the RF design and really what's needed to support the carrier now and into the future. I mentioned funding, and the key here is funding in some cases. While they do have robust funding budgets, the funding of the DAS on a campus is not necessarily a slam dunk. It's quite a lot of financial analysis is required. There's going to perhaps be some participation by you or a neutral host or a third party, but there are budgets available, and at a minimum, the carrier will provide, in most cases, the RF signal source. So they're going to make in some cases, large upfront investment in the base station or the microcell or whatever the RF sources may be. But again, it's important to touch bases with the carrier very early on so they can start doing the financial analysis and the design analysis in order to make this a successful install. The carrier can also help you understand what's going on in the outdoor space. So you may be looking at your assessment and you may have problems, say in a dorm or dorms on the perimeter of your campus. And you may hire someone to design a system, perhaps even begin installation of that system that serves those dorms, only to find out that a particular carrier has plans to build a cell site in the macro environment just a block or two away from the dorm that would solve all of the in-building problems, or most of the in-building problems that you're having in that dormitory, using the dorms as an example. So the carrier engagement early in this process will solve many potential problems for you and become a real source of great information as you plan for the DAS deployments. The third piece of this is getting an understanding of who is representing you. It's a very long process to install a DAS on a campus, and there's going to be many people, many stakeholders involved, potentially confusing technology options, carrier engagements. There's going to be the OEM solutions to evaluate. There's going to be the inevitable problems that come up and have to be resolved. And then, of course, there's going to be the deployment management piece. And in all those tasks, there needs to be, or should be, a team or individuals who represent the campus and sorting through all those options for you. And fortunately, you do have a lot of good options. Frequently, the campus will engage a subject matter expert, or a consultant. There's a number of good ones now that specialize in campus deployments, and they can take you through all these steps from the very beginning all the way to the deployment and the maintenance phase of the DAS deployment. Closely consider partnering and bringing in an equipment agnostic integrator like Goodman Networks. Goodman Networks, like other integrators, is equipment agnostic, and they're not wedded to a proprietary solution, and they can help you kind of sort out and evaluate your options, what the best track is to take in terms of the design and approach. They can help you very much so with the discussions with the carriers. Most of the larger ones like Goodman are preferred by the carriers and have preferential status, and they can assist you in representing you in much of the transaction and the deployment of the systems. I think, too, that a great option is to consult with your peers. CUDA is a tremendous organization to network and learn best practices of other universities and colleges in their deployment of DAS, and learn from them, share those best practices. And then finally understand that at some point, probably pretty soon in this, you're going to need some legal counsel. If you enter into an agreement with a neutral host or a carrier, typically contract length is up to 10 years, sometimes more. And so there's going to be a lot to consider and review in a contract involving a 10-year commitment. So be prepared to engage legal counsel on your team early to take a look at the agreements that you're going to see from the carriers and the entities involved in the DAS deployment. The fourth key here is managing your financial assumptions. Oftentimes we hear that the campus really fully expects someone to pay the bill and also pay you revenue. And that's not to say that it happens very frequently, but it's not always the case, particularly in smaller universities where there's smaller user groups, and there's not the type of revenue available to the carrier, in that case, or neutral host, to offset the big cost in deploying the DAS. The cost of the DAS can run easily into the millions of dollars on a campus, and there's a tendency to underestimate what's involved financially in making a commitment for the construction of the DAS. At the same time, the universities and campuses need to take a close look at what's their infrastructure requirement and what's the cost related to providing appropriate infrastructure services to support the DAS. I'm going to touch on that in the next slide or two. But there can be a tremendous cost for fiber transport, for example, between buildings that sometimes gets underestimated. So the way around all of this and to get the right assumptions up front is to try to conduct a budgetary analysis very early in the process to understand how viable this project is. And a system integrator or your consultant can look at what you're trying to accomplish and give you some budgetary ideas as to what this is going to cost and the financial considerations. There have been many times when a university or college has issued an RFP, for example, and gone down that road and solicited information and costs, only to be shocked to find out after that process how much these systems cost. And you're going to make a big investment in preparation in an RFP, and the people responding are going to make a big investment in their response. And if you discover early on and do some diligence through a budgetary analysis, it can really cut off a lot of the work that you may do in preparing an RFP or doing some of the back-end stuff that I've talked about in this presentation. Okay, so the fifth key is exploring the space and infrastructure requirements. This can be a real shocker for the facility, particularly as it relates to the space requirement and ultimately power, HVAC, and a T1 connectivity. A indoor DAS deployment, think of it as a miniature cell site that they're putting inside one of your buildings. And from a space requirement, a carrier is going to need a minimum of 250 square feet per carrier. So if you have 3 or 4 carriers, you're going to need, it's at a minimum of about 1,000 feet. And depending on sectorization and the size of the build, it can easily grow to 2,000 or 3,000 square feet of space for a campus installation. Now, the facility where this equipment resides and that space requirement doesn't necessarily need to be on campus, but you need to budget space for that year and understand that there's going to be a demand for space to handle the carrier equipment that you may not otherwise have available or expect in this kind of deployment. At the same time, you're going to need to plan for the fiber requirements, and there'll be fiber that will need to run between the buildings from the base station out to dorm rooms or campus buildings or the stadium or the hospital. And the question is do you have connectivity? Do you have a pipe available with space in it to pull fiber? Maybe you have some existing dark fiber, either multi-mode or single mode, but the investment in the fiber and the connection between those abilities, whether it simply be the pipe or the fiber itself, is an important consideration. At the same time, understand that many campus deployments, we think of them as an indoor solution, but oftentimes there's an outdoor component, and that is an outdoor antenna, which may be on the side of the building or two, or on a roof. And oftentimes there's architectural or aesthetic considerations that need to be considered, and you need to plan for that and understand who the variety of stakeholders are in approving antennas. Do those antennas need to have some kind of stealth or kind of a camouflage mode? What is the policy? And it's important to share that with your RF designer very early because it can influence the location of those antennas and also the type of antenna and how they're stealth. So the architectural piece oftentimes comes up kind of late in the game, but it needs to be addressed early because it does impact design and the configurations. of the build. Similarly, with the base station requirement, you're going to have some remote IDF and MDF requirements. The remote hubs are going to need to reside typically in an IDF or closet. And at the same time, you're going to have thousands of feet of coax and or fiber that's going to be typically run in ceilings. So if you have plans, architectural drawings that show existing pathways, or you understand how the best means is to pull cable above ceilings, that's going to be invaluable information to give to the RF designer. And understand if you don't have that, then that is something that will need to be understood fairly early in the design process. So those are kind of the key items to consider in terms of the infrastructure and what to consider as you begin to consider designing and building that DAS. So I've provided some pictures here. This is an example of what you might see in an IDF, an intermediate closet with remote hubs. The picture on the left is equipment on a 19-inch rack. The picture on the right is similar. The gear on the right can be mounted sometimes on the wall, but typically it is rack mounted. The next picture shows you what a full base station looks like. Now there's some components next that are part of this, UPS and HVAC, that add to this space, but as you can see, the footprint is quite large for a base station. And you are going to need, as I mentioned, a minimum of 250 square feet per carrier in most cases. And then on the right, there's a micro version of a base station. This is a Nokia unit that can be used as well. So the good news is that some of the gear that is deployed in the campus is actually getting smaller, and there's an opportunity to create some solutions where space is an issue. So the sixth thing to consider here is the maintenance piece. And the maintenance part obviously is very critical, because once it's built, if you have an outage on a campus, you need to understand who it is that you call. Who is responding to those service calls? What's the response time and the cost? Typically, a maintenance agreement will have terms in it that talk about, okay, for X amount of dollars, you get someone that will respond to alarm, say, next business day or within 48 hours at no additional cost. That might be fine in an office building, but if you have a stadium or a venue where there's critical times and you need response, let's say within 8 hours or on a weekend, you need to fully understand who's responding and what's the additional cost to you to get that response time. At the same time, be sure you understand who is it that's going to make that maintenance commitment, and what is their warranty. Oftentimes the assumption is that whoever builds the system is going to also maintain it, and that needs to be verified. Oftentimes that is the case, but it is not totally or always the case, and that needs to be confirmed very early on in your discussions with whomever is funding and committing to the DAS build for you. You should also know, is the system being alarmed, and where do those alarms go? How important is alarming to you, and is that a requirement of the carrier or perhaps the public safety entities? And then finally, what is included in the maintenance agreement? So it's not just a service tech and a response time. It can also include things like spare parts. So you want to be cautious of a situation where you have a building or a facility on campus that it's critical that the system be up, and when you have an issue that it get fixed. Well, it's tough if you don't have a spare parts kit on site, because there's some of these parts can easily take 4 to 6 weeks to procure, and our suggestion always is really to plan for spare parts, and if that your responsibility, is there a place for those spare parts on your campus? How are you going to handle the spare parts piece of the maintenance agreement? The next key is understanding public safety radio requirements. And this is becoming very important, particularly on campus environments with the concerns we've had with incidents on campus, as well as ordinance requirements that are demanding property owners to verify that coverage exists in their current buildings or buildings that are being planned. And they'll, if you're building a new building, oftentimes they'll withhold a certificate of occupancy if you can't demonstrate that you have good public safety radio coverage in that building. And when you're designing the DAS or considering the DAS, understand that the DAS on that same backbone has the capability of supporting public safety frequencies, and this is an economical or more cost-effective way to address those ordinance issues and the requirements of your municipality. At the same time, like the discussions with the carrier, it's important to understand at the municipal level what's coming down the pipe so that you're prepared for that. They may not have an ordinance now, but you may discover that they're planning one. So now is a good time to, when you're designing the DAS system, to consider, say, pulling in spare fiber, considering alternative antenna locations, all the things related to meeting the unique requirement. Finally, one of the questions that should be asked is, what's the impact of the DAS on E911 location of the capabilities and requirements? So when you install a DAS, it can have an effect on the ability to find someone who makes an E911 call. And there are very specific guidelines mandated by the FCC that if someone makes an E911 call in a facility, they have to be able to be found within a certain distance of that where that call is initiated a certain percentage of the time. And I didn't want to include those statistics because they're changing a little bit. But when you consider doing a DAS installation, talk to whomever's designed the system about how the system's going to impact E911 and be prepared to address that issue either now or in the future. There, fortunately, has new technology, pilot beacons, and things like pilot beacons that can help overcome the challenges associated with E911 location issues when you install a DAS. So there's a solution for it, but it's something that should be talked about as you consider the public safety addition to the DAS systems. Touched on that a moment ago. Going to A, verifying the technologies and the frequencies is critical. You need to confirm, which when you talk to the carriers, what frequency bands they expect you to use now and in the future. Typically, your designer will do that, and there needs to be some kind of commitment by the designer to make sure that the system is delivering what the carrier requirements are. But you need to identify the frequencies that are being used now, and then have a discussion of what frequencies may be utilized in the future, and how is my system going to adapt or be able to be retrofitted to support the new frequencies and associated technologies. I just talked a moment ago about public safety. You need to confirm the public safety frequency bands and compare that to what the DAS system is meant to support, and make sure that if you want to put public safety on that same backbone, that the hardware will support it, and also be prepared to understand if there's any interference issues related to your system interfering with the existing public safety radio waves. The other piece of this is Wi-Fi included. So many of the new systems have the ability to support in a variety of different means Wi-Fi, and be sure to ask the integrator or the designer if it will support Wi-Fi. And this goes back to number one, when you did your wireless needs assessment, is that a requirement? Is that something that you want to consider as an add-on while you're building out your DAS systems? And number 9 is understand the time and the resources to deploy a DAS. It's as I mentioned, it's easily 12 to 18 months. Some of these systems, from the very beginning, from the time you think about it, I want to pull the trigger on a DAS system, can take up to 2 years to complete. And really what that means is that you're going to need to have an individual or a team available during the duration that's kind of keeping an eye on all phases of this deployment. Oftentimes, these large installations, the people involved in them forget how long it's going to take. So you may start out with someone in your organization driving the deployment of the system and really getting it started, and then find out that 6 months into it, that person may move on into another department or another role, and you've got to retrain and re-educate an individual or a group of individuals in your organization as to where you're currently at and what needs to be done to complete a deployment that might involve another 12 to 18 months period of time. You also need an individual, as the time goes, it is extended into, say, up to 18 months to 2 years, someone who can manage all the diverse interests on that campus. And typically there's an individual or a small committee who does that. So in the end, it's a question of, who's going to be leading this effort for you, identifying that person early in the process and planning for that individual or transition to other individuals during what is a fairly lengthy deployment process. And then finally, you've got your DAS built, and it's a terrific thing to be able to get that accomplished. But in the end, you need to have a defined means of validating. Did this thing that you had built, is it really meeting the system requirements? So there needs to be a post-installation plan, a validation plan as to how to confirm that what was installed is actually being delivered. And that can be done via a post-installation benchmark study, again, using a mapping tool or software. The installation teams will frequently have that equipment. But you also, at the same time, need to understand if there's a shortfall, who's going to pay for that? Is it the installer that's going to cover the cost of a shortfall in the design? Is it the owner? Is it the designer that's responsible? Who's going to handle and manage the fixes, the punch list items, so to speak, related to system operability upon completion and commissioning of that system? So that wraps up the 10 key points. In summary, I think the key takeaway here is that early on, you have to pay attention to the details related to this deployment, and there's a lot of details, and it goes back to that assessment as a starting point, and I hope you'll consider that as a key element of your gas deployment plan. So how can we help? At Goodman, we can help with all phases of the assessment, starting from the site survey, design and scope development, carrier approvals. We are approved vendor across the country and can help with the dialogue with the carrier. We can help with the budgetary piece and help you understand what the system's going to cost, and also provide firm prices, PMing, installation, commissioning, and maintenance. So thank you very much. Please, if you have any questions, please feel free to email me or call. We'd be happy to help you with any or all aspects of a DAS deployment. Thanks for joining the call this afternoon. Have a nice remainder of your day. Thank you.